Hello and welcome everyone to the 24th project showcase in our initiative دعم الخريجين. In this initiative, which is presented by the Saudi Data Community, we aim to highlight the work of our community members via showcasing their graduation projects. In particular, we are focusing on projects which employ data science or machine learning. The goals we wish to achieve include highlighting data science and artificial intelligence projects, showcasing student efforts and enabling them to share their experiences and their stories, presenting those projects to various sectors for the purpose of finding support for our community members. We also want to encourage and to educate prospective graduate students. We want to motivate them to delve into topics such as data science and machine learning. Last but not least, we wish to enrich the community with good materials and substantial knowledge in the field of data science. In this initiative, we are targeting recent graduates and technical projects which employ data science and/or AI. We would like to thank our golden partner Quant and our strategic partner Education Statistics Center and Decision Support. Our project for today is titled Predicting Solar Irradiance in Saudi Arabia Using Machine Learning and Artificial Neural Networks. This is a project which aims to investigate the use of ML and ANN methods to improve the forecasts of solar irradiance. Our presenter for today is Sabah Al-Khaldi, mechanical engineering graduate from University College London. Welcome, Sabah. The stage is
Hello. Thank you. Thank you so much. Good evening, everyone. I'll just share my screen. Can you see my screen?
Yes, we can see it's clear.
Okay. So my name is Sabah Al-Khaldi, and my project is about predicting solar irradiance in Saudi Arabia. Some people might ask why I chose the project. My answer would be that it's mainly due to the lack of data, lack of research on solar irradiance, and the limited number of measuring devices, which sparked my interest to develop methods that could extract more valuable information of the limited available data. My objective is to investigate machine learning and artificial neural network algorithms in predicting solar irradiance. Along this aim, I devised geoclimatic zoning method to enhance the forecasts, and I increased the interpretability of the machine learning model. I will walk you through these ideas in my presentation. To introduce the general concept of predicting solar irradiance, I will explain a simplified version of artificial neural network algorithm as shown in figure 1, since machine learning regression models work on a similar way. There is a forward, so this is a forward neural network, meaning there is no feedback loop, and it's fed with historic global horizontal irradiance, temperature, humidity, and time to forecast future solar irradiance. Nodes consist of three main parts, which are input values, weights and biases, and activation function. Weights indicate the strength of a node, while a bias allows for a vertical shift of the activation function, which maps the input to the output. Next, I will show my methodology of how I explored and pre-processed the raw collected data. In my investigation and analysis of solar irradiance, I started with obtaining the data from a reputable source. Then I pre-processed and filtered them. I then iteratively analyzed 10 locations in Saudi Arabia for specific trends and possibilities to improve the current prediction models. An exploratory data analysis, EDA, for a generic year is conducted as shown in figure 2 for the location of Al Jof to represent the trends in non-coastal cities. The top chart shows global horizontal irradiance. The middle one shows temperature, which follows a very similar trend to solar irradiance. And lastly, at the bottom, we have relative humidity, which shows almost a flipped trend, which is theoretically expected as unchanged water vapor content and an increase in temperature would cause a decrease in relative humidity. This slide shows machine learning model prediction capabilities. The upper graph shows machine learning predictions against observed global horizontal irradiance daily values for a prediction window of a whole year, while training the model over 4 previous years. This split between training and testing data is chosen based on having the test set representing most of the variance through accounting for the largest scale effect observed, which is seasonality during the year. The bold blue and red lines represent the actual and predicted monthly averaged values, respectively. Daily predictions show large noise for prediction window of a whole year, as shown by the errors in the bottom graph. So what I did is that I did monthly averages, which I analyzed in terms of statistical metrics such as the R squared, showing strong accuracy between observed and predicted curves. Model agnostic interpretability enhancers are implemented to uncover the hidden trends and patterns from the traditional machine learning black box model to make it more explainable. There are various methods, however, a representative one called centered individual conditional expectation, the CICE for short, shown in figure 6. As shown in figure 6, we can see the impact of each of the main features, namely temperature and relative humidity on solar irradiance. The x-axes are the features, while the y-axis is the change in the solar irradiance. The curves are anchored at the lower end of the features to show variation through the complete range of values of these predictors. It's clear that as temperature increase, the solar irradiance increase. On the other hand, initial increase in relative humidity correspond to an increase in irradiance till around 30% of relative humidity. Then additional increase of humidity leads to a decrease in solar irradiance. However, such interpretability analysis is limited for the choice of the year, the location, and the assumption of independence of features, leading to potential misrepresentation of the reality of the situation in Saudi Arabia. For example, very low temperature and high humidity is highly unlikely in Saudi to happen. This is the second method of analyzing solar irradiance data used. This is a type of neural network called long short-term memory, LSTM for short, since it is capable of learning and forgetting dependencies in the predictions. It is both capable of learning long and short-term dependencies, and hence the name. Figure 7 shows its application to the location of Jazan as an example of a coastal city. Despite daily fluctuation causing the noise as shown in the bottom graph, the top graph shows that the method simulates the overall pattern while being conservative in deviating from the long-term trend. The metric used in this analysis is the normalized root mean square error, with values near zero indicating higher accuracies. Through exploratory data analysis, the method of geoclimatic zoning is devised, in which locations with similar geoclimatic conditions are grouped together in training the algorithms to enhance predictions. So figures, as you can see in this figure, figure 6, the max and the maximum and the minimum and average temperatures are plotted here of all locations, and they are marked with small circles. The geoclimatic zones are circled in dashed lines, as in the legend on the left side, based on locations being also first neighbors on the other configuration, which is relative humidity, which I can show you in the appendix. So using this method, I grouped locations in one circle, and through that we can analyze these geoclimatic zones, use them in the LSTM method, and we will see later how this could improve predictions. However, this method has limitations, since not all locations are grouped, as in the case for the location of Abha. The interesting part, as I said, about this technique is that through geoclimatic zoning, we get improvement in predictions. An example is shown for the coastal city of Jeddah. So both these figures show poor performance. We can see on the left, there's a poor performance for training the model only on the location of Jeddah. So the normalized root mean square error is almost, it's closer to 1 than 0, which indicates, so 1 usually indicates it's a matter of luck. So it's a 50% chance to predict like the value. So near 1 meaning it's nearer the possibility of chance. But on the right side, we can see that using geoclimatic zoning method, we get a normalized root mean square error value of 0.51 almost, which is much better predictions based on training both on the location of Jeddah and the location of Jazan. As we saw previously, they are grouped in the same geoclimatic zone. Solar irradiance, then what I did is that I benchmarked, I checked that my data's accuracy is valid enough. So I use solar irradiance datasets from the National Renewable Energy Laboratory, and then I compared it to other reputable sources for a generic year and location. Firstly, CACAIR, which is a scientific research and governmental entity in Saudi that gives locally collected data, giving 94% accuracy compared to the National Renewable Energy Laboratory dataset. The other source is the PVCEST, which is an educational software which has large data set for solar irradiance, giving almost 87% accuracy relative to the original data, as shown in the bolded curves, representing the monthly moving averages. The National Renewable Energy Laboratory data used for analysis is accurate, as both other curves give around 90% accuracy. Regardless, there are also limitations to the analysis, such as the years analyzed, which is so these are analyzed only for 1 year, which is chosen for each of the different data sets, not being representative maybe of today's time, since these data are actually collected from 1998 to 2003, and then averaged. But if we have more data, we can see probably the effect of climate change even. To conclude, I have fully investigated and analyzed all available data collected from locations in Saudi using both machine learning and artificial neural network algorithms, showing their respective accuracies of predictions. Also, correlations of features have been investigated through advanced technique that uncovers the black box machine learning model. Lastly, LSTM, long short-term memory model, showed clear improvement in predictions when incorporating geoclimatic zoning training method. Thank you so much for listening, and I would be happy to answer any question. Thank you.
Thank you so much, Subah. This was very well done. It was quite an interesting topic, and you have done a great job.
Thank you.
Uh, I wholeheartedly agree with you about the lack of data or the difficulties that you face while collecting data. Other than this point, if I may ask, what are some major difficulties that you faced working on this project, and how did you overcome them?
Um, yeah, so that's actually a good question. I would say one of the major difficulties is that I didn't know where to start.
Mm-hmm.
So I didn't know like what shall I do, which data shall I collect, and which features shall I look at. Is it temperature and humidity alone? What other features that might be helpful? Maybe time, yeah, etc. And I would say I overcome them by basically trying to reach researchers in different institutions. So I talked to people from Hail University, also KAUST, Kaker. I also talked to people from a lot of institutions actually in Saudi, just to know more about how to research such topic, such project. And also I tried to search online on people who did similar projects and then try to reach them to build upon what they did basically.
Mm-hmm. I agree with you. Guidance is very important when you are diving into something new, and reaching out to people is always a good idea.
Yeah.
If you had the chance to go back, is there anything that you would do differently?
Again, sorry.
If you had the chance to go back, is
You
there
just
anything that you would do differently, like in the process of this project? The answer
hmm.
could be no.
Let me think.
Okay.
uh, I think I will reach people at the very beginning. So I
Mm-hmm.
reached people later on, a bit late, but I would reach them at the beginning, and I would also try to uh, develop my skills in machine learning, like advanced techniques, very early on.
Mm-hmm.
Uh, but other than that, I think I don't know. There's nothing in my mind actually.
Mm-hmm. No, no, your answer is great, and also, even if there's anything that you would do differently, it's an experience that have taught you a lot. I can tell, which is great. One last
Yeah.
question. As you know, part of why this initiative is taking place is that we want to help motivate prospective graduates who are still deciding on ideas for their graduation projects. And so,
Yes.
what advice would you give them based on your experience?
So if they want to do something related to machine learning
Mm-hmm.
and predictions, etc., I would say there are also like a lot of good websites such as Kaggle, which is like a website that's
Mm-hmm.
owned by Google, if I'm not mistaken, which does teach machine learning in a very like nice way and very smooth. And also, I would say, yeah, again, just reach people who have done it before because I think the only way to learn is from like a major source of learning is from other people who have done it before because
Mm-hmm. Mm-hmm.
they know exactly the problems that happen. So yeah, I think these are
Yes.
my two
Very
advices.
well said. Very well said. Thank you so much, Sabah, for your participation. And we truly wish you the best in the future. Thank you to
Also, thank you
everyone
so
who have
much.
joined. Ah,
Honestly, thank you because the what you did in making this initiative is such a great thing actually for students. So I should be thanking you as well. So thank you,
oh,
honestly.
you are most welcome. We are very proud to have people like you with us. Thank you to everyone who have joined us, and we will see you next time with another project showcase, inshallah. Goodbye.
Bye.